Okay, folks, welcome back. Week 4 of 8th grade Westwood Science. We're going to talk about ocean currents right here in 2020. And the thing that we're going to look at first is what's the standard that the actual state would like us to know. And that comes under this Middle School Earth and Space 2-5, which the state is asking us to do a couple of different things. One is go ahead and develop and use a model to describe. Remember, models are things that describe such things as a model of an airplane. Maybe it's not the real size airplane, it's the model of an airplane. It helps describe what this airplane might do in flight. We've used models for volcanoes and all sorts of things. Well, they want us to develop and use a model to describe the unequal heating and rotation of the Earth, which causes, we're going to focus on B here, which is patterns of oceanic circulation that determine climate. This whole week we've been talking about climate. In the last couple of weeks, we've covered a few things that have been determinations in climate. Mostly precipitation is the thing that we talk about when we talk about climate, as well as temperature. But there's also other factors that we've talked about last week that cater into our idea of climate. Well, I just hope you understand that this is the most current information on our oceans. Current. Get it, as in an ocean current. So this will be great information for you. You'll sit and relax and understand that this is probably one of the best things of your week right here. And let's begin by hitting the surface of our current information. Okay. I have 3 of you probably vomiting right now. We have the surface currents is what we're talking about. Well, let's go back to what is climate. So what is climate, Mr. Jensen? I can't quite remember. Well, climate is the weather in an area over a long period of time. So if we said, what's the climate like in Spokane, Cheney, Washington? What is it like out there in Airwood Heights? Is it tropical where you've got tons and tons of trees, toucans flying around, hot all year? No, it's not like that. Okay, what do you have, icebergs and ice? No, not quite like that. The climate determines over a long period of time, what is it like in an area? We usually talk about how much rain do you get? And what's the weather like? What's the precipitation? What's the temperature like? We live in a temperate climate here above the equator. And our climate is actually pretty nice, where we get 4 seasons distinctly, and where we see ourselves here in Spokane, Cheney area. What we look at, again, is just the average rainfall over a year, or the average temperature over a year. When we talk about weather, in contrast, that's just the day-to-day state of our atmosphere. If you look outside your window right now, what's the weather like? We wouldn't ask for the climate, we'd ask for the weather, because it's our day-to-day. The weather changes within the week. So we only go up to usually about a 10-day forecast, which is really just a prediction. But within 10 days, here's a prediction of what we think it might be. But we don't know for sure, because weather changes day-to-day. In other words, we'd ask the question, what is the weather going to be like tomorrow? Now, patterns of oceanic circulation is something that we're going to look at right here. And so we talk about these patterns. And the weird thing about it is when you think about it, you go, wait a second, I'm talking about the big blue planet. And when I talk about the big blue planet, most of it is blue from our oceans, although the oceans are not blue because of the sky so much. But we call it the big blue planet because from outer space it looks blue from a lot of the oceans, which cover most of the Earth. In fact, 71% of our Earth actually is covered in water, which means 29%, if you did your math, is land. Most of it, 71%, most of that is salt water, truthfully. So if you looked at it at a pie chart, it looks something like this. Land, 29%, water, 71%. It's a good thing we're outweighed by all this water, because water is very important on our Earth. It does a lot of things to keep us alive. Without that much water, we wouldn't be alive. The percent ratio of land to water is actually perfect for life to exist. Isn't that amazing the way that came together? It might feel like we're talking about something that looks like this, but we're actually not. Different areas, there's continents. These are atolls, which are just little areas in the ocean where they create coral reefs and extinct volcanoes. But we do have 5 major oceans here on Earth, just to give you a little background information in case you're wondering. And what we see here is we see a couple of different oceans. First of all, we've got the Pacific Ocean, which is right here on the right-hand side. To be specific, we live next to the Pacific. In fact, we're right here where that red dot is. That's where we live in Cheney, Spokaneville. But the Pacific Ocean, remember, the world is round, despite what some may tell you. And so the Pacific Ocean in this picture actually wraps around to the backside, and the Pacific Ocean is on the other side as well. You got to think of this as a sphere, more or less, not a flat. So we've got the Pacific Ocean, which is our largest ocean. That's the one that borders right along us up here in the Seattle, Spokane area. Then we've got the Atlantic Ocean, which is if you go across continental over here to New York area, the Atlantic is here between Africa, South America, North America, Europe, some of those areas, all the way up through Greenland, Iceland is the northern and southern Atlantic, but the Atlantic Ocean is right here. That's the second one. Then we got the Indian Ocean, which is right over here by India. And of course, it's right off of the coast of Africa, down here in Australia and some of these areas in our Asian countries. And then we've also got Arctic up in the north, which is mostly ocean. It's a lot of frozen ice up there as well. But we've got the Arctic Ocean, very cold. And then we got the Southern Ocean. The Southern Ocean is one that's considered a separate ocean, though it looks like it might be part of the South Atlantic, South Indian, all that kind of stuff. But there's actually a circulation of current that goes around the Antarctic, and it does create its own, what we call a separate ocean, a Southern Ocean. So overall, we've got 5 main oceans. We've got the Pacific Ocean, the Atlantic Ocean, Indian Ocean, Arctic Ocean, and Southern Ocean, all coming together. And the one thing they have in common is that they all share water together. Now, the water's not stagnant, which means it's not just sitting there by itself. The water is actually moving in what we call currents, much like what you see when you watch a river current flowing down. If you threw a piece of wood in it, you'd see the wood drifting down through the current. Our oceans do the same thing. In fact, there's been times where over here in the Pacific Ocean, we've had tankers that are full of little rubber duckies or full of Nike tennis shoes, things like that have dumped over. And they've actually, those things have floated in the current and washed up all the way along the coast, right up in here and all the way up into Alaska and some of those areas up in here. So we've used some of that research to track some of the ocean currents. These are very big currents. They're not easily tracked, so it's not like we can go out and just throw something into it because the ocean's massive. But we've had some of these incidences help us track kind of where these currents go. But why, Mr. Jensen, are the oceans so important? Why would you want to do a class called marine biology and all that stuff and study the ocean and the life that's within it? Well, the oceans are actually very important. In fact, one of the things is they help maintain Earth's heat balance. Now, before we go into the stuff about currents, I just want you to kind of understand that currents are a very important thing. In fact, the oceans themselves are very important. It's kind of this weird thing. It's like the earth being able to sweat. When you sweat, water evaporates off your body. It comes out of your pores and it has heat trapped within it, so it cools your body temperature down. That's why we sweat. It's to help us cool ourselves down. That's why they tell you not to put your baby in the hot tub, is because not only is it not good for them, but babies don't have the same ability to sweat like we do as humans, so they can't maintain their body temperatures like we can. Random fact, as I'm rabbit trailing. It helps us maintain Earth's heat balance. This is because water has a high, what's called specific heat. That's just where it takes a lot of energy to raise the level of water temperature or lower the temperature inside the water. Another thing is it's an important source for our water cycle. Without our oceans being the way that they are, we wouldn't have all this fresh water dumping on our land, which is not a good thing. That keeps us alive. Another thing is it's a major source of oxygen. A lot of people don't realize this, but most of our oxygen is produced in our oceans through this thing called phytoplankton. Phytoplankton is it's just a way of absorbing some of the carbon and some of the things out of the atmosphere. It builds it into something that a lot of plankton actually eat. But the phytoplankton is just a brainless organism that basically just builds itself, and then it goes up through the ocean ecosystem through there. And then, of course, last but not least, right there in the highlighted section is oceans spread heat from a hot equator to a colder poles throughout ocean currents. So this is where ocean currents kind of come into play. It helps to maintain that temperature and everything around our oceans. It's kind of like if you have a fish tank and there's no circulation in it, it's going to get nasty over time. When you leave your dishes in the sink with water in them, over time it just gets nasty and stinky. But if you have something that's circulating the water and making it so that it can clean itself, well, that's a good thing. So we've got like this natural kind of filter on our ocean that ocean currents kind of provide for us in a sense, but also provides us spreading the heat throughout our Earth. Now let's talk about surface currents. Surface currents. Well, there's a diagram here I want to show you. And the diagram looks like this. Surface currents are driven mostly by the fact that we have wind going over the top of the ocean. How does wind come about? Well, most of that low pressure air, remember there's a lot less, could we say air molecules, I guess, that are in a low pressure, so you have a lot less condensed together. So the density of the air, how much mass is within that volume, is a lot less in a low pressure system. So it's kind of like lighter air in a sense. And when it's lighter, it kind of tends to move up. So low pressure has air that moves its way up. And as it moves up, it cools, creates a cloud due to that condensation of the cooling. And then the cloud starts to move through the air. And the reason why is we've got those global winds. It's the unequal heating of the earth. So land versus water has different heating. And because of that, we have winds, creates different pressures. But what we see is we see a low pressure being built up and it moves towards this high pressure. Why does it move towards the high pressure? Well, because all these dense molecules in the high pressure build up and start to move down. They get heavy. And as they move down towards the earth, it creates space. And so the low pressure moves to kind of fill in that space. And pretty soon you get a cycling of wind. Now, on the earth, though, what we see is we see a high pressure build up. And when a high pressure builds up, it's very packed together, complex areas. And when it does, it wants to move into an area where there's less room. Over here in the low pressure area where we were losing some of our molecules up, we actually have that. We actually have less molecules over here. So that high pressure starts to move towards low pressure and we get a surface wind occurring. That wind that occurs comes in contact with our oceans, and that's where we start our surface currents. To demonstrate this, we're going to go to our public access television here. We've got a local channel here at Westwood, and our Westwood Public Access channel has a great demonstration. We've got a couple of people that want to help us out here, and we're really happy to have them. So I'm going to turn this over to our public access channel over here in Westwood, and we'll come back to this in just a moment.